Good evening, Ravi sir.
Good evening, ma'am. Yeah,
How are you?
very good, ma'am.
Yeah, good. So we'll just start in 5 minutes because
Okay,
there was one lecture. So after that, we'll join.
sure, ma'am. No problem.
Yeah.
Yeah.
And are you still working from home or the office is started?
Uh, so it's like more we visit customers,
Okay.
so more of implementation. So like say
Okay.
2 weeks we travel and 2 weeks it will be like assisting customers from home.
Okay. Okay.
Yeah. So yeah, we
But
started
now,
traveling from June, July.
oh, July. Yeah. Yeah.
Yeah.
Actually, I mean, if the press is working, then obviously they will have the problem and then you have to
Yeah. The other
help them.
thing is most of the customers are packaging customers. So
Yeah. 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 Correct. That makes
So they
sense.
were running double the shifts, so we have to support them.
Support them. Yes,
Yeah,
I mean, packaging was one of the industry which didn't get the heat of that lockdown as
exactly,
compared to the
exactly,
commercial printers.
exactly.
So
Yeah,
the packaging allied businesses were also not in trouble as such,
yeah,
the
correct,
raw
correct.
materials and everything. So which was
Yes.
good. Yeah, that's it. We are also taking all the lectures online, so there is no in near
Yeah,
future that the college will
yeah.
start and
It's
everything.
now digital.
Yes, but
New normal.
it is, yeah, it is giving us chance to learn something new as well for us
Yeah,
also. Otherwise in daily routine we don't have time to explore anything apart
exactly.
from the attendance and marks and everything.
Yeah.
So with this kind of lockdown, we also learned many things which are good for
I,
students, I'm sure.
yeah, I guess everybody's life has changed after this
Okay,
lockdown.
yes, and we didn't know that
Some or the
technology.
other.
Yeah, yeah,
Yeah,
yeah. Absolutely, absolutely. Like we were forced to accustom to the technology. There was no
yeah,
other choice. Either
yeah.
you change yourself or stick
Correct,
to the
correct.
original thing. So
Yeah,
change is very important, and I think this lockdown really gave that opportunity for everyone to adopt that new change,
yeah.
which is good time.
I guess
So
nobody
slowly,
would
slowly.
have thought that digital classes is possible.
Yeah, yeah, exactly, exactly. I mean, on WhatsApp also there are so many messages. Earlier mother used to say, "Don't watch mobile, don't watch
Yeah,
TV, or don't sit in front of computers." But now they are, forcing. How come? How can you miss the lecture? You better sit in front of the computer or take my
yeah,
mobile and attend your lecture. So it's just reverse side
yeah,
altogether. But again, it has a disadvantages, no doubt. But still, one has to cope up with
yeah.
that. So you are basically in Mumbai only, right? You are in Mumbai?
No, ma'am, I'm based out of Delhi.
Okay, you are in Delhi currently.
Yeah, I
Okay.
travel pan India for any
Uh,
implementation customers.
all right. Okay, okay. That's nice. Okay, so we have today's slide up.
Okay,
So we'll just start in 2 minutes. We'll start so that we can
no
finish
problem.
on time.
Yeah, sure. Yeah.
Students will join whenever they are free from their earlier session. And Murad through ESCO only or from
Yeah,
uh,
yeah. I know
from
Murad. Yeah.
okay. He's my classmate actually.
Oh,
So we
okay.
were in the same class and he was my project partner as well.
Oh, okay.
Yeah. So
That's good.
whenever I have a problem, I just call him Murad help and he's a phone call away to guide
Yeah,
or
yeah, yeah, yeah.
yeah. And I mean that's what the printing industry is very close knit. They are willing to help. There is no competition as such. कि मैं इसको क्यों बताऊं?
Exactly.
That kind of stuff. We are
It
all
is
are
very small circle.
yes and very
Good
close knit.
afternoon. Good afternoon, Mr. Ravi.
Good
Oh, hello,
afternoon,
sir.
sir. How are you, sir?
Hello.
Can you hear me, sir? Hello?
Joshi sir, can you hear us?
Hello.
We can hear you, sir. Joshi sir? I think he has some connectivity
Yeah.
issues. Yeah. Shall we start? If you're ready, then we'll start.
Yeah, ma'am. We can start.
Okay. Yeah.
So, shall I start or how is
Yeah.
it?
No. Yeah. Shivam is
Sir, I will
ready.
start.
So,
Yeah, fine.
हाँ जोशी सर बोला. Joshi sir, can you hear us? I think he has left again. Shivam, you can please start.
Yeah, yeah. Good evening, everyone. I am Shivam Shailesh to welcome everyone for day 2 session of the Color Week 2020. On behalf of my class, I welcome today's speaker, Mr. Ravi Vaitiyanathan. Sir, before we start today's session, I would like to announce the top contenders in the Color Week quiz competition from yesterday's quiz. Ganesh Shedke from TE Printing, Sarang Sapkar from TE Printing, Satyam Rai from BE Printing, Shubham Naikare from BE Printing, Yogesh Arthamawar from BE Printing. I would like to thank everyone for yesterday's overwhelming response and feedback. Yesterday we learned about color and perception of color. Today we are going to learn about the transformation of color by Mr. Ravi sir. Now I request Chaitanya to introduce Mr. Ravi sir.
Thank you, Shivam. It is my great honor to introduce a great speaker, Mr. Ravi Vaityanathan. He is currently studying at ESCO Graphics, India. He has more than 14 years of experience in printing industry. He has specialization in pre-press, process standardization, design management, workflow management, project management, digital color proofing, and expanded gamut printing. He also had certified color management. He has he had Six Sigma Green Belt, which is ISO internal audit certified. Today he is going to talk about the transformation of color, and I am eagerly waiting for today's session. Over to you, Shivam.
Thank you, Chaitanya. Now I would request my friends to note down the points and questions for question answer session. And now I would request Mr. Ravi sir to start today's session.
Yeah, thank you, Shivam, and thank you, Chaitanya. So, let me share my screen. So, I'm turning off my video and just sharing my presentation. So, so I guess yesterday session you saw about how the colors are getting, how you see color, how light is involved, correct? So, so I guess this will be a two-way communication session, not just me speaking. So I encourage everybody to speak. So can somebody confirm whether you can see my slide?
Yes, sir.
Okay, fine.
Yes,
Yeah.
sir.
Okay. So I guess yesterday you saw about how the colors are perceived, how you are seeing colors, how the light is involved in colors. So what is the main role of light? So it was kind of a basic session. So the today's session is I hope it will be a continuation of yesterday's session. So it's a basic session, and today it is more towards how that color, uh, how we manage the color digitally. So because in a digital world you have to do the color manipulation, so you are recording some color data. It is transformed from one color space to the other color space. We have color gamuts, so we have calculations, we have transformation. So there are so many things involved in the color management workflow. So today we will be seeing about all those aspects in brief. So probably so you can get some idea about it. So let's move on to the session. So before we start, I just have a couple of slides. It is more towards keeping you alive till end of the session. So I'll be asking you a couple of questions. The answer will be revealed only during the end of the session. So you should be awake till end of the session to know about the answer, to know the answer. So can you see a slide with two boxes? One is kind of a bluish green and yellowish green, and in the middle there is a color. So can somebody tell me whether the colors are similar or it is different?
Sir, I would request students to please write in chat box, because it becomes difficult if everybody starts talking. So I think Shivam, if we can read out the chat box answers for sir, then it will be easier for him to understand.
Yeah, that will be great.
Yes,
Yeah,
ma'am.
Shivam?
Yes,
Yeah.
ma'am. Yeah, sir, continue.
Yeah, so anybody has answered? Yes, no?
Uh, Yogaraj Bhoi is saying difference all.
Okay,
Chaitanya
so
is
you
saying
are
different.
so the center box in both the squares. So you have a center box with a color. So my question is whether the color is same or it is different. So I guess somebody are saying it is different. So my answer is no. Both the colors are same. So I'm just drawing a rectangle connecting both the squares. So hope you can see now there is no difference. Both are same. So how this is happening? So what is happening? What is making this two look different before? And when I connect it, it is both are looking similar. So this is a phenomena. So I will be explaining about this in the last slide, extremely end of the session. So, and the next phenomena is about this particular image. So nice vacation image of a family. So there are some people in it. Sorry about the low quality of the image. So what I'm doing is I'm just adding a filter to it. Okay, so you can see the color difference. So if you look at the lady in the middle, I guess the lady is wearing a yellow tops. So can you look closely look at it? So what color it is? So it is. Can somebody tell in the chat what color it is? Yes. No. I I
With
guess some you should
filter.
see some color in it. So what is the
Yeah.
color of the
It
top?
is with
The
filter, it's
lady.
yellow.
It's yellow.
Yeah.
Yeah. So before filter.
Mangoish kind of.
Okay. Uh, I'm not sure. It should be yellow. So you should see it as yellow in both the cases. Without
Yes.
filter, yeah. So both the cases it should be. Of course, a slight bit shade of the shade might be different, but generally it is grouped under yellow. So you can say, yeah, it is a yellow tops. Okay, but if I remove the filter and put it only on that particular area, now what you say it as yellow or kind
No.
of greenish.
Yes.
Yes. So now you don't say it as a yellow, correct?
Yes.
Yeah. So the reason is again particular concept of evaluating your prints. So I will let you know what it is exactly called and why this has to be taken care. So Yeah, let's move into the session about the transformation of color. So I will be speaking about the basic color science. There are few terms which we have to make ourselves familiar before we proceed further. So, so I will just touch base on some of the key aspects. And then the next is about ICC profiles. Uh, the hope everybody knows what is ICC profile, International Color Consortium. Uh, ICC stands for, and profiles, color management profiles. Profiles vary from input, output profiles, which is widely used in the color management. We will see how that is useful, how it is working. So like say you capture an image, how the profile, the information is getting transferred, how the color calculation is happening, how the transformation is happening. So that is the main agenda of today, transformation of color. And creating profiles, if time permits, I will show you how profile is created. Of course, you would have done some. Let's see, and some useful links and how to evaluate, how to see a profile. So there are some tools available. You can open a profile and see. So I will show all those things also. Okay, so I guess this will be same from yesterday's session. So the light is mixture of different, or it's a combination of all the colors. So that's why it is white. When you pass it through a prism, you can split it, and we generally call it as a VIBGR. So the rainbow is also formed. You can see the rainbow on the based same concept. So color is not a innate property of physical objects. So it is basically a sensation primarily caused by the spectrally selective stimuli falling on the retina. So whenever you see something, it is just a stimulation of the particular wavelength. So like say in this case, if it is a red, so you can see the wavelength. So it's particular sensation which is uh, how do we say, you sense when you see an object purely because of the retina eye. So I guess which yesterday's session would have been explained to you. Okay, so some key aspects or some key attributes which we have to keep in mind before we proceed to the next topic. So hue. So hue, the perceived similarity to one of the perceived colors, like say the basic red, green, yellow, and blue and yellow. Brightness, the amount of light that appears to come from a particular area. Lightness, so there is a difference between lightness and brightness. So lightness, the brightness of an area judged relative to the brightness of a reference white. So that is what lightness is about. So if you are referring to a white object and then you are saying, so how much bright it is. So that is called as lightness. And colorfulness, so the degree to which the hue of an area appears more or less visible. So how colorful is that object? So that is based on the hue. And we have already discussed what is hue is about. So saturation, the colorfulness of an area judged relative to its brightness. So if it is more brighter, so you can see, so otherwise it will be a more darkish tone of the color. So that is decided based on the saturation. And chroma, the colorfulness of an area judged relative to an achromatic color of similar lightness. So achromatic, so that is called chroma. So I hope these are some key things which we will be speaking about today. So if anybody who is not clear, please type in the chat window. I can explain you.
Yep.
And the next is about color space. So what is color space? So color space is a geometrical representation of a color in a space. So whatever we do, we do it in a three-dimensional. So we try to plot it in a graph and then kind of a graph, and then we say, so this is how we represent in this particular color space. So usually it is a three-dimensional thing. So that is what is called as a color space. So we use a three-dimensional space to define a particular color. So the next thing is CIE-LAB, International Commission on Illumination. So CIE defines how about the illumination conditions. So you would have heard about standard observer. So this is very key thing which you should which generally we come across when we speak about color management or whenever we speak about light. So CIE-LAB is a body which defines all those standards related to light. So what you mean by LAB? So what is LAB? So it is defined by CIE. So dimension L for lightness and A and B for the color component dimensions. A position between red and green, B position between yellow. So hope you can see the axis. So if you see A is between minus A and plus A, and which is red to green, and blue is B is between yellow and plus B and minus B, yellow to blue. So lightness is in the center, so plus and 0 to 100. So that is the scale we use for lightness. So CIE-LAB is designed, this is very closely, very approximate to the human vision or standard observer. So there is one term which is known as standard observer. So I guess when you see an object, like say if I am judging a color, so I can say it as a yellowish green, or somebody might say it as a green, somebody will say it as a yellow. So it is because how they have been taught, how they have been recognizing all these days about the color. So they try to relate it and then they say this is a yellow, this is a green, this is a yellowish green. So they try to tell you the color in a particular name. So it is the way they got used to it. Okay. So, but when we speak about observer or in a color evaluation, it has to be a standard. So that's why we call it as a standard observer. So he shouldn't have any color deficiency. So you should be a standard observer. So every test, like say whenever you do a printing, so we say it has to be in a standard condition. So likewise, if you are seeing a color, we say it is a standard observer. So I will touch base on that in the later slide, what that means. So the next key thing is CIE XYZ. So this is very close representation of the human vision. So whenever we see any color, so there are two elements in our eyes, rods and cones. So they play a key role in defining the colors, how the color is seen by any observer. So there are three types. Generally, when you see a color, so there will be three values, or we cannot say three values. So basically, three stimulus we say. So so based on the cones, so there will be three different types of cones. So when you see a color, so so it senses that particular wavelength and it creates the sensation in your retina. So by default, it is classified. It is defined in XYZ. So this CIE is close to that. So if you like say if you are seeing a color, so it will be creating a stimulation of XYZ. So this XYZ is very closely mapped how a standard observer sees the color in the standard condition, how he sees the color, and how the color is recorded in his brain, the impulse pulses. So this XYZ is a close representation of how a person sees a standard observer sees a color. So that's why this CIE XYZ is very popular in color management. So whatever we do, so it's all based on XYZ and LAB values. So that's why these aspects are very important in color management. So coming to the so color spaces, there are numerous color spaces. So Mansell, CIE, Newton, these are Newton is a very basic which was the initial space, and then many people developed their own color space. But whatever we are using, it is all purely we are most closely using to Mansell and CIE uh, spaces. So we also call it as an horseshoe diagram, CIE color space. So we will be speaking more about this particular CIE color space. So coming back, so the next important thing is color encoding. So what is color encoding? So whenever you see a color, if you are an observer, you see it. This is a sensation which is observed in your brain. So it is a human thing. But when you speak in a digital world, it has to be coded, encoded, decoded. So there are some binary. So that is how the computer language works, right? So you have to quantify the data. Whatever the color you have, it has to be quantified. So that's where this color encoding comes. Color encoding is nothing but a quantified digital encoding of a color space. So earlier we spoke about color space. What is color space? So we have to quantify it. So that's where this color encoding comes. Color encoding are limited to precision and range and usually having associated viewing environment. So it is defined to a particular viewing environment. So this color encoding, like say in the bottom, so you cannot make any colors out of it from the numbers, because this is purely meant for the system to understand. So whatever the color, it has to understand. So we are using zeros and ones to quantify it and the system to transfer it. So if I say this 101, 010, 111, it's a binary data. You cannot do anything with it. So this is purely meant for the system to do the calculations. So that is called as color encoding. So like say if I say this number 101, 010, 111, so it doesn't make any sense. But the system knows how to transfer it because it's a binary encoding. So the encoded value cannot be interpreted without knowing the encoding scheme. Yes, of course, we should also know what encoding scheme I have used to mention this particular color value. And then the next is color rendering. Is it clear? I can see absolute silence. Are people able to follow? You can stop me anytime if you are unable to follow any particular thing. You can put it in the chat window. I can explain.
Yes, sir. They will ask the questions in the chat window itself.
Okay. Any questions so far? Yes. No?
Yeah, they are saying understood.
Okay, fine. Okay. So color rendering. So you have encoded a number. So that has to be converted. So that is where color rendering comes in. Color encoding intended to output on a particular device. Color cannot be viewed without rendering. So you are rendering it. So I have further slides to explain this rendering. We will be doing more things with this color rendering. And the color transform, a modification of encoded color values with the aim of altering the appearance of the encoding. So we will be further speaking about this color transform, how a particular data is being transformed or how we are altering it. So color rendering plays a key role in it. So we will be seeing about all those rendering and transform. So color gamut, so hope everybody knows it's a range of colors that can be output on a given device. Color output system have limitations on the dynamic range and chroma that can be produced. The color gamut of a particular system is typically depend on numerous factors, like say a printer, the gamut will be different, a digital printer, it is different, the flexo machine, the gamut is different. So if you look, the inks are different, the substrate are different. So there are many various factors involved in every printing processes. So the gamut varies from machine to machine, device to device. So so that is called as color gamut. So this is one gamut. So this is a very old diagram which I created during my master degree. So just comparing between a printer gamut and a monitor gamut. So just to see a different angle of the, yeah. So you can see, the different axes I have used L, A, B. So it is basically a three-dimensional thing in the LAB color space. Just to show, so, so we have covered the basics of color science. So we will move into color management, ICC profiles. So, so color management, what do you mean by color management? So like say you have an image, like say I have this particular car standing outside my house. I am taking a picture of it. So I use a digital camera. I shoot it, I save the file, I convert it, I transfer it into my PC or a laptop. So, and then I print it. So if you see, there are different, uh, what do you say, different color spaces involved. So the gamut also varies. So there are a lot of encoding, decoding happens here. So how do I maintain the colors, right from capturing it and how during reproducing it? So that's where color management comes in. Okay. So image capture devices like say scanner, cameras use a solid state array to sample colors from photographic or a scene original. Like say original in the sense when you capture through camera. Photography, if you are using a scanner to scan any photographs. After quantifying, because when you scan it, it converts into a binary code and it is quantified. The encoding channels usually correspond to the RGB filter. So even if you look at a scanner, it basically use the RGB filters to convert the light, which is reflecting from the source light of the scanner. So it converts them into the tri-stimulus value or the three major uh, thing we say it, X, Y, Z. So it converts into that. So a three color system is usually because the human visual system is trichromatic. So X, Y, Z. So that's what we may mean it as trichromaticity. So the coded values do not define the color appearance. So because when you measure, when the scanner converts, like say RGB 204, 102, 255, if I give you a value, it doesn't mean anything. It's an RGB value. So so there is no rendering or what environment I am measuring. So those aspects are not involved in it. It's just a generic value, RGB. So red is this much, green is this much, and blue is this much. So it doesn't add any other inputs to it. So RGB or CMYK values specify how a color is to be made, but not what its appearance will be, how the appearance it will be, what is the lighting condition used. So if it is a device dependent or a device independent, so all those aspects are not involved in it. So to match colors rendered on different devices, some transformation needs to be done between the input device and the output device. Like say if I'm using a scanning a image in a scanner or capturing in a camera, and then if I'm printing it, so there has to be a transformation because I'm using a RGB color space and then I'm printing in it in a CMYK color space. So this RGB values has to be transformed into a CMYK space. So how the transformation happens, how this color is getting converted, how the algorithm works. So that's what we will be seeing. So how that is done, so that I will be explaining. So color management facilitate us to control, adjust the color information across various device and media. So it is not just the transformation. So it has to be in a predictable way, and we should also have a control of the color how it is getting transformed. So that's what the color management is facilitating. So the need for understanding the behavior and characteristics of the device. And we should also understand the behavior of that particular device. So if I give a, like say, if I have a digital printer, if I give red 100, so it has to print red 100. Correct. So we should see whether the device, what is the capability of the device and how it is understanding, how it is working. So we also should understand all those behavior characteristics. And then, so for all those things, our color management tools will help us to do all these things. So color management enables to predict, control color reproduction. So there are generically two ways. So two ways of making allowance for device characteristics. One is closed loop, the other is open loop color system. So I will tell you what is closed loop and open loop color system. So closed loop color system, it is a very old technology, even some people use now. So people who doesn't depend on color management, they do a closed loop color system, which is nothing but I know I'm a particular person, like say I work for a company and I have a printer. Only I know how the device will work. If I am giving a cyan 100, whether that cyan 100 is printing cyan 100 in the printer or it is printing at 80. So what should I do to correct it? So only I know what I have to do to the printer to make it, because working with that particular printer over the period of time, I know how it works and how I have to modify the data so I can uh, get a predictable output on the device. So that is called as a closed loop color system, because only I know about the printer. If somebody is coming new and if he's printing something on the printer, he doesn't know how the colors comes out. So he has to again spend some time, see how the colors are coming out. He has to get accustomed to the printer and then he has to work with it. So this is called as closed loop color system. In closed loop system, the workflow is fixed and the operator are highly skilled. The operator understands the device well and performs set of actions that is necessary to obtain the better result. Nobody else can perform it. So this is very, very early stage and it is still practiced. So people who doesn't have a proper color management system, so this is how they work. So open loop color system. What do you mean by open loop color system? So this is like say open loop color system enables you to connect with the different devices in the workflow. This is so as an alternative of connecting each and every other device. So there will be a central connecting space, which is called as profile connection space or a color management system. So I will explain further how this works. So how this open loop system works. So like say you are, if I have a monitor, like say if you go to a print house or a big print shop, there will be a Mac, there will be a PC monitor. So they use scanners. They also take input from a digital camera. So they have a digital printer. They have a tabletop printer. They also have a press. So offset press, flexo press. So they will have different devices. How do I connect all those devices? So that should be something common. So where I can do this calculations and then transfer the color from one device to other device so I can get a predictable device. So this is achieved through profile connection space or color management system. Fine. So in short form, CMS means color management system. So in color management system, there are two key elements. One is profile and the other is color management module. So profile, we know ICC profiles, so which is widely used. There are other unique profiles also, like say in ESCO, we have our own profiles. We doesn't depend on ICC profiles. So every color management system or who have built the color management system, so they can use their own proprietary format. Like say if you are working in Illustrator, so you have a common proprietary format which is .ai, or the other interchangeable format which is called as PDF. So if you are sharing something with a guy who sits in somewhere, some other location, you save it as a PDF and then you share it with as a PDF document. So that is, so ICC profile is a common exchange format which any system can read and then they can execute the color management. And there are some proprietary formats also. So profiles, and the next is the color management module, CMM. So it is nothing but the color engine which does the conversion. So profiles and ICC profile is a data file which describes the color characteristics of a device, how this device will perform. So there are also some non-device profiles also. So what are the different types of profiles? Input profile, output profile, display profiles, device. There is also device link profile, color space profile. So there are different types of profiles. So this is again a very huge topic. I'm just giving you an introduction how things are happening. So in this, which in 45 minutes, I will not be able to cover a lot. I'm just giving what to say, just giving some brief on the basics. So if you want further details, of course, you can contact me. So next is about the CMM, color management module. So this is nothing but this performs the calculation needed to translate the color information from one color space to the other color space. Like say if you have an RGB image, it has to be printed in a CMYK color space. So you are actually changing the color space from RGB to CMYK. So this CMM or the color engine will does that translation. So like say from an RGB color space, CMM will translate to the common profile connection space, which is nothing but XYZ values or LAB values, and from that LAB values again it is transferred converted to CMYK values. So this CMM plays a key role between changing values, color values between one space to the other space. Okay, so the what is this profile connection space? So the profile connection space is the interface that provides an unambiguous connection between input and the output, and this is based on CIE. I earlier explained you about what is CIE. CIE 1931 standard colorimetric observer, which is nothing but XYZ, CIE XYZ. So this is standard for any color management device or a color engine. So it has to do the color conversion in XYZ. Okay, and we spoke about rendering indent. So there are four rendering indent. So relative colorimetric, ICC absolute colorimetric, perceptual, and saturation. So where this rendering indent is used is when you convert color from one color space to the other color space. That is where this rendering indent comes into place. So the first is colorimetric. I'm not saying whether it is relative or absolute. So because relative and absolute, the only change will be whether the media white point has to be used or it is only one white point has to be used. So I will tell you. So in colorimetric, so this is how the out of gamut colors are mapped. So the red is the bigger gamut and the blue is the smaller gamut. If you see the outer points are moved to the edge of the gamut. So this is how the colorimetric works. So all the points outside the gamut are mapped to the new gamut boundary. So basically it is clipping what is outside, it is just clipping. So what is the difference between relative and absolute? Relative to the media white point, and the other is absolute colorimetric. Like say you want to use the same white point. So example for absolute colorimetric is like say I have a digital printer and I want to stimulate the print which is printed on a gray backboard or a specific media in the press. So if you look at the white point, the substrate color varies. But in my digital printer, I have to stimulate that white point. Then we use this absolute colorimetric. So what it will do is it will use the same white point of the substrate which is getting printed on the machine. So this is widely used in the proofing stages, contract proofs, which is generated in the Epson printer, any other brands also. So digital printers. So we generally use absolute colorimetric. Relative colorimetric, the media white point is fixed, so it is not varied. So it is one LAB value. Uh, so you are not playing around with the white point. So next is the perceptual. So how when you switch from gamut to the bigger gamut to smaller gamut, all the points outside the gamut are compressed within the new gamut boundary. The relationship is maintained. If you see, you can see the relationship between the dots. Just some points, just to give you an visual explanation. Okay, and so the saturation. So in print industry, we will be using absolute colorimetric, relative colorimetric, sometimes perceptual, but we will not be using saturation. But generally, we will be using only two: relative colorimetric and absolute colorimetric. So these are just for you to understand saturation. So when you play with RGB, these rendering endurance will be useful. Saturation tries to preserve the saturation of the colors. So coming to ICC profile, so this is how a ICC profile is built. I will show you. First, I will cover the key points, and then I will open a ICC profile and then show you how you can see this tags in the ICC profile. So it is 128 byte header. So you will have a header and then the tag table and then the tag elements. So what will be in the tag? So I will show you. So if you take a RGB, like say a input profile or a monitor profile. So if you see, you will have a red track tag, green track, basically the three XYZ component. So it will how it has to do the conversion to the PCS. PCS, hope you remember, it is profile connecting space, which works in XYZ. So we are basically trying to know how the colors are getting converted to the XYZ. So LUT means lookup table. It is a one dimension lookup table and 3 by 3 matrix. I will show you in the profile so you can have a better understanding about this. And when you speak about output profile or like say CMYK profile, so it is a multifunctional table MFT profiles or used for complex RGB and CMYK input for RGB, CMYK and multicolor colorant outputs multiple. So it is a 3 by 3 matrix in so if you look at the input, it is XYZ converted to LAD and then that LAD is converted to CMYK. So in the input profile, it's RGB converted to XYZ, but in an output profile, so XYZ, which is in the PCS, profile connection space, from XYZ, it is converted to LAD to CMYK. So, and these are the tags. So I will show you how you can see this in the profile. So each profile has a transformation. It will be a B2A tag. And hope you remember we spoke about the rendering indent. So if it is what is the rendering indent using? So it will be like say A to B, A to B1, A to B2. So that is how the tag will be. I will show you. So perceptual is 0, relative colorimetric is 1, saturation is 2, absolute colorimetric uses the same. Relative, only the white point will vary as we discussed before. Okay, and I guess we are running short of time, so I will not show you creating profiles. So what I will do is and I
So
will
your
show.
voice is cutting off.
Is it clear now? Hello?
Yeah.
Yeah.
Yes, sir.
So I'm just switching to my PC. Can you see my Windows system?
Yes, sir.
So this is ICC Profile Inspector. So I will just open it. So this will help you to understand about profiles. So whatever we spoke right now, I can open a sRGB profile. So sRGB is an RGB profile, input profile. So if I open it, so as we said, so I have the header information. So and I have the tag table. So if you see, so we were speaking about R, X, Y, Z, G, X, red tag, green tag, B tag. So I will go back to my slide and I will show you. Can you see red track tag, green track tag, blue track tag? So it is the same thing over here. So so this is how the color transformation happens. So these are the tags which are responsible for conversion of the color. And if you see the PCS is XYZ. As I said, PCS is the profile connection space. So it is whatever the values, it will be converting to XYZ values. So this will help you to yeah, see more. So you can see the RGB horseshoe diagram. Can you see green and then my blue? So basically defining my RGB endpoints. And if you see, this is my XYZ white value. Illuminate X, Y, Z. So it knows what is the light source and all the other aspects. So this is for a input profile, RGB, sRGB profile. If I go to a output profile, like say ISO quoted, which is a standard profile for an offset. So if you see, so you cannot see the same tags. Now the tags have changed. A to B. 0, B2, A0, A to B, B1, A1, A2. So can you see? So whatever the rendering indent, it's also there. And A to B, what is A to B? Source to standard, destination to standard color space. So you can see all the tags in the ICC profile. So he says it is a color space CMYK output profile. So you can also see the indent perceptual. So when I select the uh, tags and then I will try to double click, open the input channel. Can you see? So you have 4 channels and the output is CMY. So this is one cool device which is easy, free device tool which you can use to read about if you want to know about profiles, if you are keen, interested. So this will help you to understand about the different profiles. So this is called as ICC Profile Inspector. I will also show you how you can download it. So I guess whatever we spoke about this transformation, so does it make sense? So whatever we spoke about the XYZ, RGB tags, CMYK, A to B, B to A. So is it making sense? So you can see all those uh, uh, elements in the profile, actual ICC profile. So this is how the color transformation happens. Again, this is a very huge topic. I'm just giving you a brief introduction, how things are happening, how it is working. So it is again a very huge topic to discuss. Okay, so that brings to the end some useful links. So I will quickly move to my browser. So this is ICC. So I use this ICC profile inspector, so which I just showed you. So there are some cool tools which can be used for understanding about profiles, and there are profiles also available, characteristics, data is available. So you can always use the ICC website to know more about the color profiles, color management part. And then some, if you are more keen on some papers, white papers and some technical things, then you can visit TAGA, Technical Association of the Graphic Arts, Society for Imaging Science and Technology. So these are some common sites which you can refer. You can download some white papers related to color management, color. So I thought it will be useful for you if you are doing any research activities. So yeah. So
Yeah,
any
so
question? Any,
we'll move to the question and answer session.
yeah. So any
Uh,
questions? So that
Sir,
should be
Omkar is
my
asking, can you explain 8-bit binary image and 16-bit binary image?
8-bit binary and a 16-bit binary image. Okay. I have to open my Photoshop. So it's basically how the data is encoded. So whether you are using a 8-bit or a 64-bit, 64-bit you get more, sorry, 16-bit, 16-bit where you get more values in it. Uh, so to give more example, I don't have anything right now. So probably I will try to give some examples. I can email you across. So about more about the 8-bit and 16-bit. So it's basically how the data is encoded and how much bytes of information you are putting in. I don't have any example to show you to explain further. So I will do one thing. I will make a note of it. I will share some examples so you can have a better understanding. Some examples to easily understand about the 8-bit and 16-bit. Any other questions? By default, there should be two questions because I have not explained about two concepts. Any other
Any more
questions?
questions, please?
Yes,
Hello,
sir.
Ravi sir. I have one question which I would like to
Yeah.
know. That suppose we are matching an ink to a certain LAB value.
Okay.
So then are we going to achieve the desired C and H value practically when we are matching it? If we put into the formula, we are getting it C and H value the same.
Okay.
But but if we try to match the only the LAB value for an ink, so
Mm-hmm.
can we get the same CH desired value?
So where you want to achieve the value, sir? Like say you are achieve in the sense where you are trying to achieve the
For
value.
for ECG.
Okay.
So we say that for ECG we need to check the U and the chroma
Yeah.
while doing the manufacturing process of an ink. We
Yes.
need to check
Yes.
it.
Yes.
But if
Yes.
suppose we only manufacture that ink with respect to LAB only, not looking
Mm-hmm.
at the CH.
Okay.
So if we match the LAB value, then can we achieve automatically the CH value which was been desired, or is it
Yes.
required to check it?
Yes, sir. No, if you are achieving the LAB, so it should, so it's basically we are defining a different, what you say, the way of measuring, you are using LCH instead of
Correct.
LAB. But if you look at the base, it is the XYZ. So you are having the values in XYZ and you are just saying whether you want it in LAB or LCH. How the measurement mode is just changing. So if you have a LAB value which is very close to the suggested one, so LCH should match. It should be where.
Hello.
Yes, sir.
Yeah. I know your voice was cracking, so I couldn't hear you. So you meant to say if LAB is matched, then the LCH has to match.
Yeah, yeah, yeah.
Okay.
Okay, sir. Akshay is asking, what problems we can face if color profile of PC and printer are different?
PC.
Yeah, what problems we can face if color
Okay.
profile of PC and printers are different?
PC in the sense you are
I think
Desktop, I
he's
would
your
desktop.
desktop.
Yeah.
Desktop, you don't use a profile. So, basically, you will use a input profile, like say your monitor profile, and then you use a printer profile. And since you are viewing the data in a monitor, so if the monitor you use a sRGB profile, which is of a wider gamut, bigger gamut, and if you are using a particular make, it will be different. If you are using a Apple monitor or a Apple laptop, so it will be different. So if you are trying to achieve the output gamut, like say you want to, you have a printer. So normally how the color management work is, so we try to stimulate the print. We have an output profile in the software, so it can show you how it will be printed. So we will stimulate visually to show how the colors will be printed. So if you are not using a profile or if you are using an incorrect profile, you will not get a predictable result. So one time you might get a color, and the second time it might be of a different shade. So there will be there will not be a standard because you are not using any color management. So the profiles are different and you are seeing it in a bigger gamut. So this is what generally happens in the industry. So they don't know what is coming in the output printer. So they give some color values and they when they print it, it comes in a different color value, and then they go back to their system. They try to manipulate it, change it, and then again do a printout and see whether it is matching, and then they do this trial and error method again and again until they come achieve a satisfactory result or a predictable result.
Ajay is asking which profile is used widely.
Profile in the sense, if you are speaking for a monitor, it is different. If you are speaking for an offset process, it is different. So it depends what you are trying. So if you ask for a customer, like say if it's an offset customer, ISO quoted V3, which is widely used. And if somebody is very color management oriented, and they might use FOGRA, Greycall. So there are different standards, and so if it is very generic, ISO uh, ISO quoted V3, and for the monitors, Adobe sRGB, which is widely used.
Sir Vijay is asking, can you please explain about device dependent and independent workflows and how the designing softwares play role within the workflows?
Okay, so I guess I forgot to tell you about in the presentation. So device independent. I guess I have device independent. Okay, I guess I have not mentioned it somewhere in this slide. Okay, so device dependent color space in the sense, as we spoke before. So it is for that particular device. So if I use one particular printer, so I can make a profile for that printer, and then I'm mapping to it. So device independent profile in the sense, we use a common color space. So the values, it will be in LAB, so it is device independent, and it doesn't consider the white point. So we are saying that will be the common white point. So white point can be varied from device to device. So the substrate will vary. So device independent is a common profile which you can use it for multiple device outputs. So that is called as device independent, and device dependent is with your variables are fixed. So you are with one particular device, one particular media, so one particular substrate. So that is a device dependent thing. So when you go with a device independent color space, which is PCS, so that's where this profile connection space comes in. So this is a device independent color space, which is nothing but XYZ values. So which doesn't consider the substrate, what is the lightning effect, environment, so all those things.
Sir Omkar is asking, while color matching, can LAB values be perfectly matched in practical life?
Sorry, can you repeat that again?
Yeah, sorry. While color matching, can LAB values be perfectly matched in practical life?
Yeah, yes, we can do it. We can achieve. So that's why we have the LAB values thing. So it is practically possible. Many color management workflows are defined, and it's implemented uh, in such a way.
So, yeah,
Yeah, sorry, go ahead.
yeah. Pranali is asking, is there any rendering intent preference which to use when?
So as I said, the generic rendering indent which is used in the industry is relative and absolute. Absolute is used when you are trying to stimulate, like say, I have a Heidelberg machine and I am printing something on the Heidelberg machine with a different substrate, like say gray backboard. But in the industry, they provide a contract proof. Contract proof in the sense a color managed proof for approval where customer can see how the colors are getting printed, so he can approve it, and then the machine team will use it to match it in the final print. So that is called as a contract proof. So contract proof are done in digital printers. So where we use a absolute rendering indent. So what we can do is we can stimulate the colors of the Heidelberg machine, the substrate properties in the Epson printer, any brand printer, and then I can stimulate the white point of the substrate white point in my proofing substrate. So absolute rendering indent is used over there. So for the relative coloring, colorimetric relative rendering indent, so it is used in other color management places like say machine 1, machine 2, machine 3, machine 4. So that is where the relative colorimetric indent is used. So these are the widely used rendering indent in the print industry.
So can we achieve delta E is equal to 0 practically in any condition?
No. So delta E of 0, because we, as you know, in print industry, so there are a lot of variables which needs to be controlled. And even if you take a device repeatability, so there will be a tolerance of delta E. So literally speaking, so delta E, 0 delta E is it's practically it is not possible, but theoretically we say it is possible. But actually it is in the generic world, it is not possible. Any device, even if you may buy a color measuring instrument, any spectrophotometer, there will be a repeatability factor which will have a point 2 delta E or a point 1 delta E. So whatever, so there will be a tolerance value to it. So practically you cannot achieve 0 delta E.
Okay, sir. Any more questions?
So if not, I will move to my last two slides, which will be covering the answer for the questions which I received from the
Yeah.
there is some difference in color. So this is similar to the square slide which we saw first. Is it same or is it different?
Different.
So it looks different, but literally it is both the images are same. But how come it is we can see it as different? Because there is an phenomena called as simultaneous color contrast. So the first slide what we referred. So this is basically our eye try to adapt to the colors which are surrounding. Like say in this image which is on the left, we have a blue shade, but on the right side it is of a pure white. So that's why you can see the color difference. So generally when we do a contract proof, so what we suggest customer is take the entire layout. So whatever you are preparing, take the entire layout. So don't take any particular image and try to output it and see whether it is coming good or bad. Take the entire layout, print it, uh, and then see how the colors are coming. So this is purely because of this particular phenomena called as simultaneous color contrast. Based on your surrounding colors, your the evaluation varies. And this also reminds you that you should not depend on your eye for any color measurement. If you are measuring, evaluating something, use devices.
So Omkar has a question.
Yes.
Shivam, there are one. Yeah, sorry.
Yeah, what's the lowest delta E we can achieve practically?
So there is no straight answer for it. So every reproduction or every color transformation, whatever you do, so there will be a tolerance value. And if you are following any standards, so by default there are standards which give you a tolerance. Tolerance in the sense minimum maximum, like say 0 to 2%, 0 to 3%, 0 to 1%. So if you are using a spectrophotometer and if you are measuring color, so there will be a repeatability, like say you one particular color patch for the first time, if you are measuring, it will give you one value, and then you measure it again, it will slightly vary. So there will be a difference of zero point 0.1 delta E. So it depends what you are trying to do, what at what stage you are doing, what kind of measurement are doing, so that it is not defined. So, but standard varies, and every standard has a minimum tolerance value which should be followed, like say delta 2, delta 3, which should be followed as per the standard what you follow. So we cannot generically say, so this is the minimum thing, so this is the maximum thing. So every stage or every process has its own tolerance values.
Sir, Ajit has a question.
Yes.
Delta E formulation for all printing processes is same or not?
So delta E, again, there are different formulas, and the widely suggested one is delta E 2000. Sorry, I have to use the Google to show you. Yeah, so the delta E 2000, even if you look, delta E has different versions to it. So the latest one is delta E 2000. So even if let me quickly show you other example also. Let me open my color palette. Comparing. So if I go to this delta E, there is here delta E classic, delta E 94, delta E 2000, CMC 2.1, delta E 2000 2.1. So if I select the things, you can see the values, delta E values also differ. So again, this is getting improvised every time people try try to bring changes, fine tune things, and the latest suggested one is delta E 2000. So that's the latest delta E formula, you can say. Okay. Any?
Yes, one more question from Ajit.
Yeah.
Yeah. Can you explain about TVI and DGC curves?
Okay. TVI curves and DGC curves. So DGC curve is a dot gain curve, like say from one device to another device, so there will be a dot gain difference. So let me quickly see whether I can pull you some sample. Okay, so DGC, so this is a dot gain curve, but this is very linear, but this will not happen in the practical world. So every system, so it's basically 0 to 100. So from device to device, this varies. So this is called as a dot gain curve. So like say in 0, it will be like 0, in 5, it will be 8, uh, 10, it might be 15. So from device to device, it varies. From process to process, it changes. So that is called as dot gain curve. And the other is TVI. To show you about TVI, how do I show a TVI? 1 minute, I'm just trying to see how can I can visually explain you. Yes. I'm just doing some basic things just to show you. Okay, I don't have. So this is the TVI curve. So if you see the differences, and it's like I have 0 to 100, and this is the percentage, uh, like say 10%, 20%. So how much, like say in 0, whether it has to be 0, in 25, I can have a 10% of dot gain, and in, like say in 50, I can have a 20% of dot gain, 16%, 17% of dot gain. So what is the dot gain percentage I can have? So that is how this is plotted. Okay, does it making sense? So this is the dot gain curve. So it is basically saying 100, how much you will get. What is the value you are getting? 100, whether it is 18, 19, but over in a TVI, so in 10%, so what is the difference you get? 10, it is like 5% extra, 6% extra, 8% extra. So in 50%, whether it is 17% extra, 20% extra. Yes, is it making sense? Hello?
Sir, can you please turn it to the full screen?
Uh, Full screen.
It is in full
Which,
screen. Yeah, students, you need to zoom your mobile screen to see what sir is trying to show.
so this window I cannot make it bigger. So probably you
Yeah.
have to, if you are seeing it on mobile, it is very difficult.
No, they can zoom the mobile screen. That is doable
Okay.
on their own. Yeah. I think we have one. We have time for only one last question, which is by Taraki. So Shivam, if you want to ask that.
Yeah. Taraki is asking, what is the selection criteria for rendering intent for G7 as well as ECG?
So, so G7, so you are trying to follow a particular set of procedures to achieve a curve, curve or a reproduction. So G7 is a process how to achieve something. But in ECG, it is a expanded gamut printing. This rendering intent comes into play only when you play with two gametes. So like say I have an CMYK device 1 gamete and the CMYK device 2 gamete. So that is where the color transformation happens, and that is where you are following a rendering index. And generally we use relative colorimetric rendering index. Absolute is used when you are trying to stimulate something on the like say on a digital environment. You are trying to stimulate a particular press condition in a Epson printer. So that is where this absolute colorimetric comes in. Otherwise, it is relative colorimetric index. So your question is kind of ECG expanded gamut printing, and G7 is a methodology of setting up some standards. So it is not a clear question. So it is kind of a way. So the best way is if you are playing with one color space to the other color space. So the general rendering indent is relative colorimetric indent. Absolute is used when you are trying to stimulate a press condition on a digital environment. So that is where that absolute comes in. Or you are trying to stimulate a particular white point on your digital environment. So that is where it comes in. So when you speak about G7 standards, your LAB values is predefined. So your substrate values are defined. So this is the white point of my substrate. So you have to use that particular substrate. If you are not using that substrate, your first qualification is gone.
Are we done with the questions? Yeah, I think so.
Yes.
So the one last concept which I should answer, because I showed you a page. I will quickly switch to the first initial slide so you can. So we were speaking about this particular image, like say this the dress it's of yellow. Even if I add a filter or remove it, you can still see it as an yellow. The same thing for the background, like say the water. Even if I apply a filter on top of it, still you see it as a blue, correct? And even if you see the background, the plants or the trees, still it is green. You don't say it is of a different color, correct? Yes. So this is purely because of this particular concept called as chromatic adaptation. Our human visual system is trying to adapt. Like say if it is a scenery, and even if you are applying some filter to it, your plants, you assume that it is in green. Your human visual system is trained in such a way, so the ocean will be of in blue color, the sky is of blue color. So your visual system, your brain is fine-tuned in such a way that even if you apply a filter, you see it as green only. Take an example of Apple. Apple, you can try this experiment. Apple always appear red, whether you view it at night with less light, like say in a candle light, or any other lighting conditions or in a day, it is still red color apple. But if you take any other object and you see it in a particular lighting condition, it will be of different color. And then if you see it in a daylight, it will be of a different color. Few objects or few colors which we got used to in our daily life, our brain, our visual system has been adapted in such a way. Even if you see in a different lightning condition, you say it is a red. You don't say it is a apple is of a different color. So you can see, you can do this experiment, so you will come to know. So this is to emphasize that do not depend on your eye to make any color judgments. So you have to use a instrument. So that brings to the end. Thank you everybody for joining this session, and thank you, ma'am, for providing this opportunity to speak with these students.
Thank you, sir. Thank you. So yeah, Shivam.
Yeah. Now can I ask Swati Nahar ma'am for the feedback for today's session? Swati.
Yes, I'm
Yeah.
there. Good evening, all. Thank you so much, Mr. Ravi Vaitiyanathan, for providing such good information about transformation of color. The session was very good as you covered such typical topics such as color space, color encoding, color transformation, ICC profiles, open loop and closed loop, color management, etc. And it is very much expected from students that they learn a lot and also enjoyed a lot, as the session was very enthusiastic also, because it is compulsory to have knowledge about colors while connected to printing technology. I want to say thank you so much to Ravi sir on behalf of Department of Printing Technology, PVCOET Pune. And definitely, sir, we will be looking forward to such wonderful sessions in future also, because it is very good for our students for gaining knowledge. Thank you so much once again for clearing all basic concepts of color. Thank you, sir.
Thank you. Thank you so much, ma'am.
Yeah.
Yeah. I
Uh,
would like to
thank
ask
you, Swati.
Joshi sir if he want to share some comment. Joshi sir. Akshay Joshi sir. Yes.
Yes. Uh, Thank you, Mr. Ravi sir, for giving such a informative session to our students. I think they have really got a good clarity on what you have explained about the basics of color and moving into what does a profile has, what are the contents in the profile, what is the profile, what is its validity, and what is the rendering intent, and the other factors which are associated with color. So it was really a very informative session, and as Swati has also said that we look forward to have such interactive sessions in near future, so that we develop a good color knowledge base at our PVG COET. Thank you.
Sure, sir. Sure, sir. And I guess some students will be working closely with me for ECG.
Yes. We are going to be there.
Yeah, yeah.
Yeah. I told you on that day also. I will call you later on. I'm
No problem.
almost in a finalization of the proposal.
No problem, sir. No problem. Good,
Okay.
good to have a base, so we can start working on the ECG people.
Yeah.
Students.
You will hear the good news from me very soon.
Yeah.
Okay.
Sure. Thanks. Thank you, sir.
Okay. Thank you.
Thank you, Swati ma'am and Akshay sir, for the wonderful feedback. Now we have come to the end of the session, so now I request Vaibhav to give the vote of thanks.
Thank you, Shivam. I would like to thanks Mr. Ravi sir for today's wonderful session. The session was very informative and knowledge based. We really appreciate your efforts and time. I thanks Swati ma'am for her feedback. I also would like to thanks all the staff member of Printing Engineering Department for their continuous supports. Also, thanks you, SC, T, and B students. Lastly, I would like to thanks my friends Chaitanya, Aditya, Pranali, Shubhangi, Ajay, Vijay, Riya, Gargi, Pranit, and Pratik for making today's session great session. Last but not the least, I thanks Shivam for conducting the session smoothly.
Thank you, Vaibhav. Friends, please fill the attendance form, and the quiz will be on 7:30. It will be posted on our college WhatsApp group, and also fill the feedback form. Thank you, everyone.
Okay.
Thank you.
Thank you, sir.
It was well
Yeah.
organized. Thank you. Thank you so much. Thank you, ma'am.
Yeah. Thank you, sir.
Thank you,
I hope you
Srikala,
enjoyed.
for organizing.
Thank you, sir.
Yes, sir. It is students' thing. I'm done
No,
anything. I just
you have
yes,
taken a
sir.
very good effort. Really, thank you.
No, sir. It's my pleasure. Yes. All right then, students. We hope to see you tomorrow, and today's session is over. So we can leave. Shubham, sir, if you want to stop the recording.
No, actually, I have just switched my device now. Unless until the whole student are leaving, we can't stop.
Oh, is it? Okay,
Yeah.
that's fine. So can you able to remove students by any
No,
chance?
if I remove them from this link, then they won't be allowed to get enter in again. They need
Again.
the
Okay,
permission.
for
Yeah.
tomorrow. Yeah,
So we'll
okay,
wait
okay.
for the people who are
Them to
leaving.
wake up and leave.
Yes. 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 Yes.
How was it today's session? Did you like it?
Good. Yeah. Yeah.
Yeah, fine. It is very hard for second year students, to be honest,
Mm.
to understand what's going on. But still, at least they have to get introduced some of the other time. It is better. Yeah, Riya Palhade, Prathamesh Kolte, Sanmay Jain, Omkar Gaike, please leave the meeting immediately. Riya Palhade, Omkar Gaike. Yeah,
Okay.
okay. All
Done.
right then. Bye.
Yeah. Thank you. Bye.